Welcome, everyone, to Science from the Fringe. I am Professor Jay Bhattacharya. I'm speaking with Laura Kahn, who has written a fantastic new book with the title One Health. The goal of the book is to talk about the history of investigations into infectious disease outbreaks and to put COVID in a historical context. Welcome, Laura. Thank you for joining me.
Thank you so much, Jay. It's a pleasure to be with you.
So Laura, I wanted to start. You've titled the book that your One Health. It's a fantastic, really interesting read. But I have to start with a confession to the audience and to you. When I first heard the word One Health, it was in the context of a research agenda that I thought that was associated with people like Peter Daszak. Peter Daszak, of course, very famously is the head of the Eco Health Alliance that got a lot of money from the U.S. National Institute of Health. But then collaborated closely with the Wuhan Institute of Virology in a research collaboration that I think, it looks very suspiciously to me like may have been the cause of the pandemic. And the One Health agenda, I thought, was Peter Daszak's agenda.
Right.
That it's like his idea of like go find dangerous viruses in the wild, bring them into labs, with the nominal argument that it was going to somehow prevent pandemics to do that, make them more dangerous. But that is not what I learned in the book. That is not what One Health is. And in fact, I'd love for you to tell folks what One Health actually is.
Well, it's a lengthy history, and One Health is a relatively new term, but really an ancient concept going all the way back to Hippocrates, who said in his books on airs and places and waters that environmental health basically impacts human health. And when they noticed that when people would go to low-lying swampy areas, they would get sick. And it took 2,000 years to figure out that mosquitoes spread malaria. But it's this recognition that illness was, impacted by the environment around you. And you fast forward, many centuries, and there was a lot of collaboration and cooperation between physicians and veterinarians in addressing health issues. And so, for example, there was a case in I guess it was the Middle Ages, where rinderpest was devastating the food supply. And the Pope at that time asked his physician to look into it. So the physician did, and the physician suggested that they kill all the sick animals and bury them in lime. And they did that, and that stopped the rinderpest outbreak. Now, rinderpest is related to measles. It's a very deadly disease of livestock, and it devastates, ruminants.
It's one of those. It's one of the major examples of a disease that we've actually eradicated thanks to a
That's
vaccine.
right. Smallpox and rinderpest are the two diseases that we've eradicated. Major breakthroughs, and so anyway, so there was a history of veterinary medicine and human medicine collaborating. You had Rudolf Virchow in Berlin, and Dr. William Osler, who went over to Germany to study under Virchow. Virchow coined the term zoonosis, meaning diseases of animals that infect humans, and it was interesting that his father was a butcher. So he, examined thin slices of meat and found parasites in the meat, advocated for food safety inspections of meat. Osler learned from him, went back and founded, and Osler was the father of modern medicine. But when he went back to Canada, he founded the Department of Veterinary Pathology and worked a lot with his veterinary colleagues. So there was great overlap between the two. And unfortunately, at the turn of the 20th century, they got a divorce. Medicine and veterinary medicine got divorced. And part of that might have been the development of the car, because a lot of veterinary medicine focused on horses. And when horses were your primary means of transportation, their health was extremely important. So once the the dependence on horses started to diminish. The role of the veterinarian diminished as well, and they went their separate ways. So, but as we've discovered, as the 20th century and the 21st century, the microbes don't necessarily see a distinction between us and the other animals, and so the goal of One Health is to try to bring that collaboration back in so many important ways. The veterinarians have been recognizing these connections for many decades. Dr. Calvin Schwab, a veterinary epidemiologist, coined the term one medicine, recognizing that animal outbreaks can impact human health. And, that was a common veterinary term, unknown to human medicine. So when I came upon this in the early 2000s, I discovered the veterinary medical literature. And it was just a wealth of information that just wasn't discussed in human medicine. I mean, in medical school, in all of our training, not once did I ever hear the term zoonotic disease. Not once, because it just wasn't part of the medical lexicon. And that's a serious problem. So the whole goal of One Health then is to bring that back, to broaden the scope of medicine, to think beyond just the walls inside or the clinics inside your facility, to view the milieu in which your patients live. Why did they get this infection? Not just, here's the antibiotic for it and go home. What contributed to your illness? How can we prevent this from happening again? Understanding that we live in a microbial world, that our bodies are mostly microbial, that these microbial ecosystems are as important for health and well-being as any organ. And so we really need to rethink, our whole approach to medicine. And One Health is there's the push in medicine to subspecialize, to focus on just organ systems. One Health is an effort to think broadly, to counter that super subspecialization, and to think broadly across human, animal, plant, environmental, and ecosystem health. We literally incorporate the environment into our bodies every day by inhaling air, drinking fluids, eating the plants and animals that we call food. And if they're contaminated, whether it's the air, the water, or the plants and animals, if they're contaminated with one microbe or another, we're getting sick. So One Health is a way to look at that, to identify the connections, to reestablish the collaborations between medicine and veterinary medicine. It had absolutely nothing to do with manipulating viruses for some weird scheme. Where that came from, I have no idea, but I was
Laura,
just
like what you described is so. It makes complete sense. Like it's like we are part of a broader ecosystem, and of course our health is impacted. And of course, if we're going to think about our health, we should be thinking about the broader ecosystem, and the kinds of people that have that specialization in animal medicine, of course, should be collaborating with human doctors. But I want to explore the question just before just for a second about like how did it become like the idea of like what I thought before I read your book and met you, what One Health was, the narrower idea was it was incredible utopian scheme of cataloging every single virus on the face of the planet.
Right.
and going out into the wild, finding them, and then doing manipulations on them.
Right.
Where at least the civilian justification was we can develop vaccines and intelligence about which ones are likely to make the leap.
Right.
How did it get to be such a narrow utopian thing? I mean, dystopian, frankly, it turns out, rather than the broad, sort of expansive kind of vision of us in harmony with our environments, working to understand it so that we can improve human health. How did that change get made?
Great question. Well, look, we're curious beings. We're a curious species. And, you can go back to Linnaeus, who, wanted to categorize life. And I can understand the desire to see, well, what virus is out there? What's the viro? What's the, microbiome of not only our bodies, but the planet? What microbes, what pathogens are out there? I can understand that curiosity to go out there and to identify novel, you know, pathogen species the same way naturalists like to go out and identify new, frogs or, lizards or whatever. I mean, there's an inherent curiosity that we have, and people want to go out there and do it. And if you can earn money doing it, if you can get grant funding to go do that, all the, more reason why people would want to do it. I understand that rationale. My problem is taking it to the lab, identifying these microbes out there in the world, and then taking it back into the lab to see, well, let's see if we can make them deadlier. Let's see if we can make them more transmissible. I don't understand the rationale for that. I really don't.
It strikes me that at least the civilian rationale given makes no sense. Like, are there actually vaccines that have been produced out of this? Are there actually?
No. I ask colleagues who are, work in vaccine development. They don't use that research. Not at all. It's as far as I'm concerned, unethical, immoral research. I mean, just because an experiment can be done doesn't mean it should be done. And we have a lot of prohibitions against unethical human subject research. From a long line of atrocities, whether it was the World War II, experiments versus the Tuskegee syphilis experiments against poor black men. There's a long history, unfortunately, of unethical human subject research, and we've made efforts to try to prevent that. There is no history with biotechnology research, unethical biotechnology research, in the same way that we have with human subject research, and we need to change that. We need to have the actions set up to prevent.
Yeah, it's not just that it's. I mean, unethical is right, but also there's a question of like what risks should scientists take on behalf of the public at large, right? So, like, just think about the development of the nuclear bomb, right? There was a deep worry that the nuclear chain reaction set off. Like when Fermi sets off the nuclear chain reaction in Chicago, the first one. There was this worry that would it stop? Was it a chain reaction that would like consume the entire world?
Yeah.
Scientists then were taking risks. I mean, they'd done their calculations, thought, okay, this is gonna damp out eventually. It's not going to lead to a conflagration of the entire world if you start it, which turned out to be true. But in a sense, they were taking risks on behalf of every single human being
and every single life form on the planet. Yeah, no, you're absolutely right. And, after the explosions at Hiroshima and Nagasaki, those scientists were starting to feel guilty. They're having a little remorse about what they unleashed. And Einstein and some of his colleagues established the Bulletin of the Atomic Scientists just to warn the public, to provide that kind of, information to them about, warning them about the potential dangers of this kind of technology. And, they expanded beyond just nuclear. I mean, I was one of the early columnists writing about the dangers of, biotechnology. But from a government, regulatory standpoint, we don't have those systems, and we have biosafety, the biosafety levels, but we don't have bioethics for biotechnology research at the same level as we do for the human subjects research. Yeah. And that needs to change.
So can we talk a little bit about the zoonoses? You mentioned that's a major topic in the book, and there is a history. It's not that there aren't any spillovers at all from.
They happen all the time. Yeah.
So
go ahead.
No, no. So like, I would love to hear your point of view about like what makes those kinds of zoonotic events more zoonoses spillover events more like in the news recently has been avian flu, for instance, like
Right, right.
which is spread I think primarily in among domestic chickens and some other populations, but has not really made the leap into humans very much. I think there's in this year there have been 30 some cases to date at the time of recording
Right.
of this H5N1 avian flu. I mean that's a zoonosis. That's a disease that
Oh,
some
absolutely.
humans can get from
Absolutely.
animals.
Yeah. Well, there's a lengthy history of zoonotic spillover. The Black Death in the was it the 13th century? They found that when the Mongols were invading, they were coming from the steppes, and the prairie dogs that were living on those steppes had fleas, and those fleas hitchhiked onto rats. It just kind of spreads out. I mean, these zoonotic diseases are usually spilling over into us because of our activities. I mean, if we left the environment and the ecosystems and the animals alone, they wouldn't be spilling over into us. But, a lot of it stems from our quest for meat, for animal proteins, for animal products, whatever they might be. These wild animals harbor pathogens, whether it's on their fleas or whether it's if you're cutting down the trees, a lot of these mosquito-borne diseases, mosquitoes are, many of them prefer to feed on birds. But when you cut down the trees and you remove that habitat, they start heading towards human, settlements and start biting the humans instead. So, it all comes back to haunt us. Whatever we might do, thinking that we're making things better for ourselves, has unintended consequences. And there's now 8+ billion of us on this planet. There probably isn't a place on Earth that we haven't altered in some way, shape, or form. And the more we do it, the more we chop down forests, it's going to come, Mother Nature only has so much patience. And she's going to come and, return with a vengeance, as we are discovering
Yeah. I mean,
increasingly
I
these
I think of
pathogens.
this often as I mean, like my training is in economics and in medicine. So and both fields I think have at their center this idea of trade-offs, right? Any
Right,
drug you give will have some side effects.
right.
Every policy you implement will have some side effects. And the question is like, do we have some understanding of what we're gaining for what we're giving up? Um,
That's right.
and uh, and it strikes me that what you're talking about is exactly that, right? There's
Yeah,
this, and
it's a
there's
trade-off. It's a
right.
trade-off. We have 8+ billion humans, and most of us want to eat animal proteins in some way. A lot of these spillovers are either directly or indirectly related to our quest for meat or animal proteins. We either eat the wild animal, we either catch them or have them in the wild markets, or we have thousands of animals congregated together in these large, concentrated animal feeding operations that helps facilitate pathogen transmission. So, a lot of it's our activity. I mean, look, even the domestication of animals, you go back far enough, Rinderpest, Rinderpest, as I had mentioned, was a disease of livestock, and that eventually spilled over and became measles. So, it's our activities. The more we interact with these animals, the more they're,
Yeah.
sharing their microbes with us. The exception is tuberculosis. That appears to have been a uniquely human pathogen that
Mhm.
we gave to the animals. So, bovine tuberculosis, we gave it to them. So it's not just a one-way street that, oh, we're so innocent, they're giving
Well,
us all these nasty pathogens. Sometimes we give it back.
as you said, Laura, we are in what's the right word? Like in
Yeah,
communication,
yeah,
biological communication with our environment. Of course,
that's
it's
right.
going to be a two-way street.
That's
Um,
right.
and the question then is just like given that it is a trade-off, how do we take mitigation measures that are reasonable, that allow us to have some of the good things, with less likelihood of some of the bad things that come out, right? That to me is like the essence of policy.
That's the key question. And that's a question that One Health is well positioned to try to answer because, the goal is to look at this broad societal challenge, find the connections, and try to develop policies that maximize the benefits and minimize, the costs. All of our wastes that we're producing, whether it's greenhouse gas waste, whether it's fecal waste, whether it's plastic waste, all of the things that we're creating, generating these wastes and putting them into the environment, they're creating serious costs. The greenhouse gas wastes from all of our combustion and all, that's causing climate change. The fecal wastes are driving antimicrobial resistance because they contaminate the environments, the crops, the water. People get sick. They take more antibiotics. So the more fecal contamination in your environment, whether it's human or animal, and we're producing trillions of kilograms of these fecal wastes, and nobody talks about that. We've got 8+ billion humans and 30+ billion domesticated terrestrial livestock. I'm not even talking about aquaculture, producing trillions of kilograms of waste, and there's no sanitation system at all for any of the animals. And some countries don't have sanitation systems for humans. So when we talk about antimicrobial resistance, for example, nobody's talking about the environment. But that's a huge driver of illness. There was a very interesting paper that found that in New Zealand has some of the highest antibiotic use per capita. Now, why is that? Well, one explanation might be because they have much more sheep than they do people, and those sheep are contaminating the environment with their fecal waste, and people get sick, and they take antibiotics, and they get a lot of resistance. Similarly, India's got, limited sanitation systems for many people. They're openly defecating. They've got lots of animals roaming the streets. They're defecating. They've got some of the highest rates of childhood stunting in the world because the kids, they're so busy, their bodies are so busy fighting off illness that they don't have the energy to grow. And antibiotics are used they're freely available over the counter. So they're taken. They have some of the most resistant pathogens in the world in India.
This is an area I've actually published papers in on antibiotic resistance. And actually, just a personal anecdote. I was born in India in 1968, and I'm about 6 foot tall. Many of my cousins are much shorter than me. They grew up in India. I grew up in the States. Mm-hmm. It's just very, very different. I mean, that environment has a direct impact on child health.
Absolutely. Yeah. Look, I wrote my second book, One Health and the Politics of Antimicrobial Resistance. I wrote that book because medicine and veterinary medicine were pointing fingers at each other as to who was to blame for the rise of antimicrobial resistance. But when I looked at the environmental component, it was just shocking. Antibiotic resistance genes are ancient and they're everywhere. And by our massive uses of antibiotics and our massive production of fecal wastes, we are changing the microbiome of the planet in ways that we don't understand. We're increasing the expression of these resistance genes. They're already out there. We're increasing the expression of them. They're being spread far and wide by wildlife and by fecal wastes. So it's not sustainable.
I think the key idea there is it's not zero waste. That's not possible. The question is what's the trade-off? Like what sorts of policies would gain sort of the most benefit for humans while minimizing some of that risk, right? So
so there's an interesting point. So you've heard of the Green Revolution, right? Back in the 1960s, Norman
Borlaug and
developed these new crop varieties that were resistant to environmental insults. That was a big plus. On the other hand, those crops required a lot of pesticides and they required intensive fertilization. And so instead of using a lot of the fecal matter that the livestock were producing, they switched to high nitrogen fertilizer. So the fecal matter wasn't being used from the animals. You started to divide out livestock production from crop production. The fecal matter from the animals was just collected in these large lagoons. They're, releasing methane, and they're contaminating the environment. Meanwhile, these high nitrogen fertilizers are a major source of nitrous oxide into the atmosphere, major potent greenhouse gas that's being used in agriculture. And the soils are being depleted because they're not getting the organic material from the fecal matter that's just being stored in lagoons. So all these efforts at, improving, food production has the unintended consequences of, we're not doing it in a sustainable way. Between the fecal waste and the greenhouse gas waste, again, One Health looks at these connections of, this problem's leading to this problem. Well, how can we then develop policies to make agriculture more sustainable so that we're not contaminating our atmosphere and our soils and waters, and we can maintain healthy soils and healthy people and animals too? And we're not having those discussions.
I think this is exactly the right kind of conversation to happen. It's a very productive conversation. I think the One Health framework is a really a productive way to look at this. But I want to bring back our conversation back toward COVID, because that's
Sure.
the major theme of your book.
Right.
There's a history of zoonotic spillover. Obviously, that we've talked. We just barely touched the surface here. COVID arrives in 2020. Late 2019.
Right.
And almost immediately, people start talking about the idea of a lab leak origin as a conspiracy theory. They jump almost immediately to a zoonotic spillover event as the very likely, with the Hunan wet market where they sell like meats and exotic the seafood and all whatnot as the primary place where this leap happened. And in fact, I've looked at some of these FOIA documents. There's essentially a concerted effort by some of the top scientific bureaucrats of the world who fund a lot of the scientists who do work in this area, to say that this is with certainty a spillover event from the Hunan market. So now, what's your view on this? Like, how did your view, like, what did you think at the time, and how did your view develop as you looked at more evidence?
Well, it's funny. I remember when SARS first appeared back in 2002, 2003, and it kind of slowly percolated along. And I watched it slowly spreading. And my first book, Who's in Charge, was looking at the response to that. The U.S. dodged a bullet with SARS because we never really got any cases. It went to Canada and it went to other countries, and it was contained fairly, relatively short period of time with simple public health measures. No vaccine was ever developed. So with that in mind, when COVID, SARS-CoV-2 first appeared, I suspected the same thing. It would be slowly, spreading, and, we would watch it, but that's not what I saw. It was like a runaway train. I mean, it was spreading much faster than SARS-CoV-1. So that was the first inkling that this isn't quite the same.
I had the same observation very early on. It looked. I first thought was like SARS.
Yeah.
But SARS, I think, spread via fomites. I mean, it was very inefficiently spread between humans.
That's right. It wasn't an efficient virus. It wasn't, spreading quickly. And
Whereas SARS-CoV-2, it was, like I saw the outbreak in Wuhan just like everybody else, but then there were like cases very early on reported in Iran, cases
yeah,
reported very early on in northern Italy, of course, in Sweden, and then the
right.
United States, and then
It was like an avalanche. It was just
yes,
a global avalanche that was hurtling towards us. It
and
was,
then there was like evidence of airborne spread very very early, I thought,
yeah.
and yet the public health authorities didn't really.
Well, which is surprising because when I was examining some of the early, for my book, I was examining some of the early New England Journal of Medicine articles, and the authors were in China, and they said, we suspect this is airborne in the tiny little print. Tiny little print. We suspect this is airborne.
Yeah.
Nobody read the tiny print. They're just saying, "Oh yeah, it's droplet. It's not going to be. It's going to be like SARS-CoV-1. It's not that efficient." They insisted on it,
I I remember
but
there
it
was
wasn't.
I remember an early study, or maybe it's not even studies, like anecdotal report of like somebody at a Chinese restaurant in China. On one side of the restaurant has SARS-CoV-2, has COVID.
Right.
There's a fan or something, and then somebody at the other side of the restaurant gets it. I'm like, this is an airborne disease. This is not something that's going to be just die on its own like SARS-1 did.
That's right. It was clear from the very get-go that this was not the slow-moving, the flow of lava, slowly moving towards us. This was an avalanche,
Now,
so that was the first thing. The second,
just before.
yeah,
Oh, sorry. Go ahead, Laura.
yeah. So
Yeah.
the second thing that was really weird was, on Twitter at that time, people were making comments about fern cleavage site. And I hadn't heard fern cleavage site. I mean, I'm not a virologist, but there was a lot of chatter about that. And I said, please explain. And they said, well, this is just something that indicates that this virus was manipulated very early on. There was a lot of concern, a lot of chatter about the structure of this virus. Uh,
I heard the same chatter,
yeah.
but then I was involved with a whole bunch of other controversies of my own. And I figured I'm not going to launch myself into something where it's not my particular
Right.
expertise.
I did not want to make any comment on something that I didn't feel I quite understood, so I watched it. But very early on, that was a concern. And then the other thing that was just so surprising was these papers that were published that said, this is natural. We insist this is natural. Don't look anywhere else. Anything that you consider that's not natural, you're a conspiracy theorist. And that action just was really, it just rubbed me the wrong way. Like, why do you even have to say that? Why do you have to announce that this is a natural spillover when we don't know? Isn't that a little premature to make that kind of, conclusion? And
So Laura,
yeah,
can you talk about how it was established that the original SARS-1 2003
right,
was zoonotic?
right,
Because
yeah.
I think it's very interesting.
So I was curious, and in the research for my book, I compared SARS-CoV-1, MERS, and COVID. I looked at everything aspect about them.
MERS, that's another coronavirus-like
That's another
disease
coronavirus that spilled over in 2012 in Saudi Arabia. So
from camels. That
from
was
camels, that's right. So I decided to look over what was the gold standard criteria used for SARS-CoV-1 and for MERS to determine that these were natural spillover events. And for both of them, you had antibody and viral genome evidence in the animals. In the case of SARS-CoV-1, it was palm civets, which is an exotic animal that I write about in the book. And you had occupational antibody evidence in the people working with the animals, much higher positivity rates, occupational data in the workers than in the general population. So that was with SARS-CoV-1. With MERS, it's even stronger because they had archived blood specimens going back decades in camels with antibodies to MERS. And they did serologic data studies of, large.
Serologic is like checking your antibody level prevalence in certain populations.
That's right. So they did a huge antibody seropositivity rates across Saudi Arabia. They studied 10,000 people from all the provinces, and they found rates 15 times higher in the camel shepherds and 23 times higher in the slaughterhouse workers. And it matched the MERS data from the camels. So you heard the term "show me the money." I'm saying, show me the serologies. Without serologies, your arguments are dead in the water, because what we used for SARS-CoV-1, serology in the animals, serology in the humans, they match. With MERS, serology in the animals, camels, serology in the slaughterhouse and the shepherds, they match. Voila, spillover. Great. So what about with COVID, SARS-CoV-2? Zero data, zero animals tested positive. That by definition should mean it wasn't a natural spillover. Zero.
So
No occupational data in the humans.
yeah.
None.
I mean, that's such a classic One Health idea, right? So look at what's
Right.
happening in the animals, look what's happening in the humans, and
That's right.
then make inferences based on the correlation between them.
That's right.
I do want to bring up one. There was a paper that was published just recently in I think Cell, that makes the allegation that there was in the Wuhan wet market a cage with raccoon dogs that had SARS-CoV-2 positive samples. And the people that published the paper and a lot of the press around it asserting very confidently that we found the culprit. It's this raccoon dog. What's your view of that evidence?
Well, was it from serology from the raccoon dogs, or was it from the cage itself?
From the cage itself.
Okay, so
Yeah.
if it's not serology from the animals, then somebody could have contaminated. You need the serology. Show me the serologies. If you don't have the serology from the animals, and there's no serology from the occupational workers in the market, without that, you're dead.
Yeah.
That just doesn't cut water.
I mean, it's interesting because there was a lot of human DNA also found in the same site,
Right.
and so it's one of these things where like a correlation it does not imply causation. You don't know the
Right.
direction of the spread of
That's right. Now, what I would have loved to have seen was occupational data in the lab. That's not forthcoming. And it's not like China didn't have the experience of knowing what to do. They had SARS experience. So they had plenty of experience knowing what they needed to do to get, the serologies from the animals and the serologies from the workers. That data is just not there. Now, without that data, you cannot say this was a natural spillover. Period.
Right.
You just can't.
Okay, so that's. I mean, I lean in your direction on this. So I just
Right.
full disclosure to the folks who are listening. So I'm very sympathetic to that view, but I want to just take the like I want to make sure that we talk about all the hypotheses, right? So
Right.
so there, I agree with you. I think a lot of the data that have been put forward on natural origin is quite weak,
Yeah.
right? It's on the nature of correlation. It doesn't match the kinds of pretty definitive evidence that we have on SARS and MERS, right? That was very, very definitive, and it happened fairly quickly. Like the set of animals
That's
were
right.
identified fairly
Similarly with
quickly.
H5N1. You go all the way back to I think it was 97. It was H5N1, high path avian influenza, was circulating in the poultry flocks, and it was spilling over into the humans. They slaughtered all the birds. It ended the outbreak. But that didn't. The virus has been slowly moving around the world. We're watching it, and that's a natural spillover.
Yeah.
We've been watching this virus since '97, going around the world, and now it's wreaking havoc in our dairy industry. So that's
But it has
and
not made the jump to humans as yet,
well, yes, it
very, very
has because
efficiently.
it's getting into the
The eye, like,
fungoids with the eyes.
yeah.
So you're getting the occupational data.
But the point is that it's like not very efficiently spreading into
That's right.
humans
It's
as yet.
not. It's been taking decades. Just like
Yeah,
in the camels, it was decades before it spilled over. It's been taking decades. We're watching a slow, a slow
yeah.
avalanche of this virus, but
So
it's a long time. It's not the rapidity that we
and
saw.
the point is that like you can see it's spreading in animals,
Yeah,
and you can see like so it's like a classic zoonosis. It's not. I'm working on some lab somewhere, and my gosh, the only place the disease happens is right where where the lab is and all
yeah,
that.
that's right. That's right.
Okay. Now, how about the other idea that it is a lab leak, right? So, what would be the nature of the evidence that would convince us it's a lab? You mentioned already the furin cleavage site. The furin cleavage
Right.
site is a feature of the molecular structure of the SARS-CoV-2 virus
Right.
that makes it more easy for the virus to enter human cells. As a
Right.
particular, basically takes advantage of a particular mechanism that human cells have. Actually, I think all mammalian cells have for entry of foreign substances into cells.
Right.
If you have this furin cleavage site, viruses have a much more easy path into entry, right, or a very particular mechanism of entry. Other coronaviruses do not have a furin cleavage site.
None of them have a furin cleavage site like SARS-CoV-2. That's right.
And I've seen other evidence people put forward, like the codons that code for the furin cleavage site have a particular bias toward human
Right. It's
codons for arginine.
unusual configuration. The
Right, and I've seen
that's right.
there's other like molecular biological evidence, like so Alex Washburn and his colleagues have put together evidence about the presence and the spacing of endonuclease sites all through the SARS-CoV-2 virus, the viral genome. Um, I think all that's really interesting, but is it definitive?
Like I said, the definitive proof that we used for SARS and for MERS was the matching serologies, and from a One Health perspective, animals and humans, you need to have both. By definition, a spillover from an animal to a human or from a human to an animal. It's a spillover. But we care about the first one because that's the one that set off this chain reaction.
Yeah.
Um, so, so without,
Okay.
as far as I'm concerned, without that, and that's what we used, historically. But, in terms of proving a lab leak, well, what would prove it is somebody comes with their lab book and says, oh yeah, I was doing this experiment and this animal bit me, or, this test tube broke and I, inhaled the fumes. If you
But
look at,
you don't even necessarily need that, though, Laura, right? You could have a leak that's in the environmental systems in a lab, for
oh,
instance,
sure, yeah,
like a filter, so that someone doesn't even know that they broke a test tube or whatnot.
right. But if you look at some of the previous reportings of exposures, it's often human error of something that went wrong. And look, nobody's going to admit this. Why would they? I mean, oh yeah, we screwed up. We
Tens of millions of
we
people have been
didn't
hurt.
follow the right biosafety guidelines, or we did it in on a biosafety on an open bench rather than in the spacesuit airlock system. Yeah, we just didn't do it right.
Okay, so
Sorry.
you're getting to the key point. I think that I wanted to like make sure that we covered the purely scientific data point of view. It's still ambiguous.
That's right.
Right. Purely is so you have a balance of probabilities. And so the question then is not but then you also have very strong incentives for people who might have been implicated as the cause of the lab leak to say no, it wasn't.
Right. Why would they admit error? There's a
Yeah.
tendency to not want to say, "Oh yeah, I screwed up and I caused a pandemic that's killed millions around the world." Who's going to admit that? Nobody.
Yeah.
there's zero incentive
Yeah.
to admit that level of catastrophic
And
mistake.
I'd go further, Laura. There's an incentive to cover up the evidence because
Yeah,
nobody wants to be blamed for it.
right.
In fact, there's a debate that happened, I think, in 2010, 11, 12, regarding the research agenda of taking viruses from the wild and like augmenting their capacity. And there was a major fight among scientists where people like Tony Fauci took a particular side. In
Right.
fact, I read a piece that he wrote where he specifically wrote that even if this kind of research augmenting viruses to make them more transmissible and more pathogenic, even if it causes a pandemic, the knowledge gained from it will have been worth it. This is a published paper in 2012 that he wrote.
Yeah, well, he wrote an op-ed in the Washington Post. Is that what you're referring to? Saying
There's
that?
both. There's both that Washington Post op-ed and also in Molecular Biology. He wrote
Yeah,
another
yeah,
piece.
yeah. So,
Um,
he was defending this work. Look, I was surprised when I was doing my work, looking at the history of coronavirus research. Virologists had been inserting furin cleavage sites into the spike protein of SARS-CoV-1 since 2005. So this isn't a new phenomenon, a new research endeavor. They've been doing this for a long time. They've gotten better at it, and eventually it appears to have come back to bite us.
Right. So if we're doing an evaluation, it's not a purely scientific evaluation. It's a scientific evaluation combined with almost a forensic evaluation of the incentives of the people that were involved potentially. Right. That's to me is the thing that has convinced me that it's more likely a lab leak. Right. The incentives were to suppress the idea, even the possibility of a lab leak, and the incentives played out. It's not theoretical. There actually was a cover up of the lab leak idea in 2020 by the top funders of scientific research in the world. People like Jeremy Ferrara, people like Francis Collins, and people like Tony Fauci.
I can't comment on that because I don't. We can speculate all we want, but from a motivation perspective, why would these people want to say, "Oh yeah, we funded that work"? There's again, like with the Chinese, zero incentive to say, "Oh yeah, oops, maybe we shouldn't have funded this work," and sorry, zero incentive to own up to their potential role in this catastrophe, global catastrophe. So
Yeah.
I suspect, Jay, that we will not truly know until 20, 30 years when all the players are gone, that the truth will finally come out because, it's just too painful to realize what happened. And I suspect that, we're not going to, the papers will not be redacted until many years from now. That's my prediction. And it's going to be up to future historians to investigate this, but you're going to have to wait until all the players are no longer on the scene to be able to get the true story out. And unfortunately, we won't. We may or may not be privy to that, depending on how long we're around. You know what I mean? So
Yeah.
that's what
So
I think.
I hope it's sooner rather than later, but
I hope so
suspect
too,
more.
but that's my prediction.
So that brings me to the last thing I wanted to address in conversation with you today, and that is the recent Stanford conference where you were a fantastic panelist on a panel talking about gain of function, about the origins of COVID and the regulation of virology. The conference I helped organize the conference. In fact, I thought of the idea for the conference.
Yes, thank you very much for
Oh well, I mean,
that role.
I was so delighted you agreed to participate, Laura. It meant a lot actually, because well, let me describe the genesis of it. Like I've been very involved in the COVID policy fight for now basically since the beginning of the pandemic. It's been very like it's been very difficult to try to get the kinds of conversations I thought were necessary to get to good policy,
Hmm.
basically throughout the pandemic. I wanted some sort of conversation like that to happen in 2020. In fact, I tried to organize a small debate, and despite support from the former president of Stanford 3 presidents ago, not the one that was currently in power back then, I still couldn't get a discussion about COVID policy going. In 2022, I went to the dean of the medical school and I asked if I could arrange for a conference like this, and he said that in April of 2022, 2 years into the pandemic, he said that it was too early for a dispassionate academic discussion about COVID policy.
Wow.
So in 2024, when I finally got, sort of the support I needed to run it, I was absolutely thrilled. Basically, this is what I believe universities are supposed to be for, is to
Absolutely.
impanel these
Yeah.
kinds of discussions. And I wanted the the conference to be filled with people who disagreed with me about many things,
Right.
because that's how I learn about things, is by talking with people that I don't necessarily agree with about things, but also like to present the widest range of views. I put the conference together with that in mind, but when the conference first got announced, it was really amazing to me to see some of the scientific community essentially react very vigorously and negatively to the possibility of having such a conversation.
Right.
And Laura, I have to say, I was you'd already had agreed to be on that panel, and you defended the conference publicly. I thought that was really brave of you to do that in the face of this this attempt to sort of suppress scientific discussion. I'd love to hear your point of view about the because first, the conference, in my point of view, was a tremendous success. We actually ended
Yeah.
up having the kind of conversation I wanted. But like, I'd love to hear your thinking about agreeing to participate in the conference, the controversy around it, and the fact that I think it was really your panel, the panel on COVID origins and the regulation of virology, that turned out to be like the most controversial in one sense. I tried very hard to get people like
Right.
Peter Hotez, for instance, to participate on that panel, but he didn't. He said no. I'd just love to hear your story about
Yeah,
that.
well, we've been talking about the evidence for or against natural spillover versus lab leak, and, I had finished researching and writing my book, and I had come to my conclusions. Uh, but nobody wanted to talk about it. So here you have a conference that is like the only one that wants to discuss these issues. And of course, I'm going to say yes, because I mean, nobody else wants to talk about it. So I was thrilled that, that you and your institution took the lead in opening up the discussion of what happened, and why is this so political? It's a discussion that, we need to have if we're going to move forward. We talk about a sustainable future. We have an obligation to leave our descendants a habitable planet, and we're failing. And we need to at least start the dialogue if we want to make any progress. So I was very grateful that.
I wish all scientists had your spirit about that. It's been disheartening, I have to say, to see the use of this. I mean, basically, there's power in convening conferences, right? Because you can set the agenda, and
Right.
the normal. In normal science, so this is the kind of science I've been involved with most of my career. That I mean, obviously, people have points of view, but the general idea is to include all like points of view that are worth hearing.
Right. Right.
And there's a conference apparently being organized in Japan in December by a bunch of virologists that impinge on this issue. And I looked at the set of people invited, and there's basically no one on the who supports the idea that it was possibly a lab leak.
Right. Well,
Um,
I mean, if it's being organized by virologists, they have an agenda and a conflict of interest, I would argue. Um,
I mean, that's the question, right? So, like, the support for virology comes from governments, from people,
Right.
from taxpayers, right? They're not funded generally by corporations or private. And the question is like the support. Then, if that's true, are they serving the needs of the people that are funding them? That's us, the taxpayers, or are they suppressing or harming our interests? I don't think that they understand what that fact. What that means then is that they have to, if they try to hide this conversation, which is happening in the scientific community, whether they like it or not, they lose public trust.
That's right.
I've lost trust in them, Laura. I have to say,
Yeah.
I can confess, I don't believe a lot of what they say.
Yeah.
Even on the scientific side, it seems like they're trying to blur things in favor of a predetermined conclusion as opposed to an honest evaluation of the evidence, one side or the other.
Right. Well,
And if I've lost public trust, a lot of the public will lost trust. I think a lot of the public will start to lose trust.
well, if you look back historically, the U.S. had an offensive bioweapons program up until the late 1960s. And what prompted Richard Nixon to end that program? There was a series of mishaps that were done during the course of research for offensive bioweapons. The press publicized it, and there was tremendous public outrage. And there was so much public outrage at the revelation of these mishaps that it forced Nixon to renounce the whole program. The problem today is we don't have a unified press, or a press that's at least providing dispassionate, this is what happened, without any editorializing or, making it more entertaining. It was just Walter Cronkite, this is what happened today. And we don't have that in our news today.
I'd go further.
System.
It became the
Arguing
press.
with each other. Yeah.
The press attacked people who raised the possibility of a lab leak as
Right.
conspiracy theorists.
That's right. So without a dispassionate press, we have a real problem, and everybody's in their own echo chamber, depending on which media they're listening to or reading. Everybody's getting different news now, so the ability to get public consensus on any issue is virtually impossible in today's climate.
But
So,
but Laura, the flip side of that is it allows people who are press savvy in the scientific community to use the press to like essentially gain ascendancy of their point of view, even when the scientific evidence doesn't necessarily support them. And I think that happened during the lab leak discussion today.
that's right. And they had legitimacy with the press, with the mainstream media, and it's a very very chaotic ecosystem that we're dealing with today. So, how do you reach consensus then with the public when even the scientists themselves can't reach consensus, and the press isn't helping this whole situation? So that's that's the scenario that we're living in today, and getting public policy or public agreement on these issues is really challenging.
All right, so Laura, I'll let you have the last word, and hopefully more positive one. What do we do going forward? How can we have these conversations? And what do you like? You said 20 years for this to resolve, but how can we help make that happen a little faster if possible?
Well, Jay, you are playing a key role here by having these podcasts, by holding these conferences, by hosting Voices of Dissent, is an incredibly important role that I hope to see more of. But I hope we're not just speaking to the wind, and that that our conversations take traction, that that more of the public hear. So thank you for the work that you're doing. It's
And likewise, Laura, I'm so grateful to have gotten to know you and to read your book. And folks that are listening, it's Laura's new book is called One Health.
And the politics of
and the
COVID-19.
politics of COVID-19, right? So,
Yeah,
it's a really interesting, worthwhile read. And you're right. I think it's really it's these conversations that will
yeah.
hopefully reestablish the integrity of science and scientists in reality, and then subsequently in the public mind. So this has been Professor Jay Bhattacharya talking with Laura Kahn, an expert in infectious disease and origins of COVID and many other topics, and one of the main players, main folks in the idea of One Health. Until next time, this is the Science from the Fringe. Thanks for listening. Take care.